Hey guys, welcome to the last lesson for this unit. Lesson 6. Our topic today is more related rates problems. And we're going to get started with the warm-ups. So please pause the video and try the warm-up on your own. It says sand is pouring from a pipe at a rate of 16 cubic feet per second. So again, what is this? Since it's per second, it has to be the rate, and cubic feet has to do with volume, so this is dV dt, right? 16 cubic feet per second. The units give away a lot of information too, so be careful to read the units and understand what they mean or what they represent. The falling sands forms a conical pile on the ground. So a cone is being formed. The altitude of the pile is always 1/4 the diameter of the base. So these questions always will have some kind of relationship going on, because if you look at the formula, there are two variables. And if we take the derivative, we'll have actually 5 unknowns, right? Out of the 5, we must know the 4 unknowns. But if we, for most part, we are not always given the 4 unknowns. So it's always, you will be doing some kind of substituting, writing in terms of either, R or H, in terms of R or H, depending on the question. And how do you do that? We have discussed this in the past also. Here the relationship is actually given to us. If it's not given, you set up a proportion. So it's saying my altitude, which is the same word for height. So my height is 1/4 my diameter of the base, right? I know my diameter is what? 2r, right? My diameter is equal to 2 times radius. So my height will be what? 1/4, 2 times r. So h is equal to r over 2. If I want to solve for r, it'll be 2h. I don't know. These are the two relationships. And depending on what is being asked in the question, I might end up using one of those. So part A says, what is the rate of change of the altitude? At the instant, the altitude is 4 feet. So here, I'll just say A. So it's asking me the rate of change of altitude, meaning it's asking me for dH dt, right? I want to find that when my height is 4 feet. So I am going to be substituting in my equation r with 2h and then taking the derivative of it, right? So my volume is 1/3 pi r square h. I'm going to substitute r with v equals 1/3 pi. My radius is what? 2h square h. So now my equation is in terms of h, right? So that would give me, let's go back to a red. Actually I'm going to do 4/3, right? Pi h cubed. Right, we're good with that. Now let's take the derivative. So it would be what? dV dt equals, it'll be just 4 pi h square dH dt, right? I want to find dH dt. So I already know my h, I already know my dV dt. My dV dt is 16 4 pi, h is, it said 4 square, and dH dt. So if I cross multiply, this would be what? 4 squared is 16 times 4 is 64. 16 divided by 64 pi equals dH dt. My dH dt would be 1/4 pi. So that's the rate of change of the altitude. Part B. What is the rate of change of the height of the pile at the instant that area of the base of the pile is 36 pi feet square? So here again, they're asking me to find dH dt, but I'm not given the height or the radius, because if I was given, I could have used one of these relationships and found the dH dt, right? Because my dV dt is given to us. So, but what is given to us? The area of the base. So your cone is this. This is what your cone looks like, right? So what is the base of a cone? It is a shape of a circle. So that can help me find the area, because my area of a circle is what? Pi r square. So A is 36 pi and I can find r from here. The pi's cancel out, r is equal to 6. So again, if you look at your volume formula, your r, if you know your r, you can find h using r, but you do not know your dr dt. So again, you will just write your volume formula in terms of h. So if r is 6, your h is going to be r divided by 2, which is 6 divided by 2, 3. So your h is 3. So basically I'm taking the derivative of this equation here. I'm going to box it, right? Because I'm not going to again substitute r for 2h and do that work. We've already done that work once, so we can keep using it for the remaining of the question. So volume equals, I'm going to just take the derivative, which we do have it. I could have copied it from there, but let's do it again. dv dt equals, will be 4 pi h square, right? Because the 3's cancel out, and then dh dt. Don't forget that. So now all you need to do is substitute. I know my h is 3, I know my dv dt is 16, equals 4 pi 3 square dh dt. I want dh dt by myself, so this would be what? 3 square is 9, 9 times 3 is 9 times 4 is 36, so 16 over 36 pi. So dh dt equals 16 over 36 pi, and you can cancel that. That would be 4, 9. So 4 over 9 pi feet per second, because it's height. Okay. So now part C, it says what is the height of the pile at the instant. So it's again asking me height. So the whole question actually is asking me height, giving different things, right? Height of the pile at the instant, the rate of change of the volume is equal to the rate of change of the area of the base. So this is even interesting. So when it's dv over dt is same thing as dr dt, right? That's what it's saying. So here I'm going to rewrite this formula here. Let's do this here. So C would be, I know, I'm going to rewrite this fact again. dv dt is equal to dA dt. So now, what was my dv dt equal to? It was 4 pi h square dh dt, right? And if I take the derivative of my area, this would be what? 2 pi r and then dr dt. I want to find what? I want to find dh dt. That's what I'm looking for. Oh, sorry about that. I'm looking for dh dt. But I don't know. I can't have two variables. I don't know this. So what do I do here? So whenever a situation like this happens, it does not mean that you did something wrong. That was your basic instinct. You started off with that. So how do you resolve it, right? So that kind of puts things in perspective and tells you that, you know what, I don't know this dr dt. How can I change it? What have I been doing? In part A and B, you saw we wrote our equation in terms of h. We substituted r with 2h, and that's what we did. So let's do that here too. So my area was what? Pi r square. So I'm going to substitute r with 2h, right? Isn't that what the relationship we came up with? R is 2h. So this would be what? Area is 4 pi h square. Now take the derivative of it. So dA dt is what? 8 pi h dh dt. So I'm going to basically substitute this side here with this, right? That's what I'm going to do. So I'm going to rewrite this whole thing again. So my right side was good, because I'm looking for the height, I'm looking for h, and you'll see now, since we wrote both our equations in terms of h, my dh dt will cancel out. Don't cancel your h's, right? My pi's cancel out, and now let's see, what are we left with? We are left with 4h square equals 8h. Set it equal to 0, 4h square minus 8h equals 0. Factor out the 4h, I'm left with h minus 2, right? Teed out, and h is equal to 0. Height can't be 0, right? In this thing, it does not make sense? So your height would be what? 2. So that's what part C was, right? It was a little challenging question, but again, go with the flow, read the question, what it's asking you for, and if you were to do the units, it is 2 feet. Okay. Now, part D, it's saying what is the height of the pile when the rate of change of volume is equal to the rate of change of the height of the pile. So something very similar, but here my dv dt is same thing as dh over dt. So I'm going to do d. My dv dt is same thing as dh dt. So I'm going to use my volume formula, which is what? Which we have already been deriving it so many times. I'm just going to copy it from there. So dv dt is equal to 4 pi h square dh dt. I know my dv dt and dh dt are same, so can I not cancel them out? Or if you feel like for substituting it and then canceling it out, that would be good. So this is basically dv dt. I can cancel these out. So what am I left with? 4 pi h square is equal to 1, not 0. Please note that, right? So I'm gonna h square equals, solve for h, right? 1 over 4 pi. Take the square root. Pi, it's positive, so it's gonna be 1 over 2 rad pi. And that's your height, feet, for when the rate of change of the volume is equal to the rate of change of the height. They are a little crazy questions. I'm not going to deny that they're really involved and can be confusing. So try them a few times and you'll be good. So let's try another one. It says water is poured into a conical tank that is 24 feet tall and has a diameter of 20 feet. So basically this is what? 24 feet and my diameter is 20. So my height is 24, my diameter is 20. So what can I say? My radius is going to be 10, right? Now it's saying write the formula for the volume of the cone of water in terms of H. So I need to get rid of my R and write that in terms of H. So for that, I need to use my R and H and come up with the proportions. So you can, doesn't matter, you can do H over R, R over H. I'm guessing we all are good with that. You just cross multiply, so you get 24R equals 10H. Since I'm solving for R, R is equal to, and I can simplify it, it'll be 5H, 5H over 12. So that's what my H is. I'm going to write my volume formula, which is, it's not asking me to do anything, just asking me to write my volume formula in terms of H. 1 over 3 pi R square H. That's your cone formula for volume. I'm going to substitute R with what? 5 over 12 H squared H. This would be actually 5 squared is 25, so volume is 25 pi h cubed over, what is it? 12 times 2 is 144 times 3 has to be 432. Yes, and that's your volume formula in terms of H. So that's what it asked you. Now it's saying when the volume of the water is increasing at 3.4 cubic feet per minute. Again, look at the units, cubic feet per minute. Per minute is your rate. Cubic feet means volume. So dv dt is 3.4 and it's increasing. So it's going to be positive. And the height is what? 2. At what rate is the height of the water changing? So I'm looking for dh dt. So I'm going to use this formula here, right? I don't need to use the one with r because I do not know dr dt, and I want to find dh dt. So all I'm going to do is write this formula. I'm not going to rewrite it actually, I'm going to just take the derivative here. So dv dt would be what? This is the formula here. I simplified it. So that would be 25 over 144 pi h square dh dt. Yes, the 3 goes into 432 144 times, right? We just saw that over here also, if you were to think about it. Now all I need to do is do my substitutions. I just need to solve for dHdt. So this is 3.4 equals 25 over 144 pi. My h is what, 2? So 2 squared dHdt. Simplify all that. I'll get 2 squared is 4. 4 times 25. I can cancel that out. 4 goes into 144 36 times. Right? So I have 3.4 times 36 over 25 pi. So I think you can use the calculator here. So I did put it in the calculator. 1.558 feet per minute. Oops. Per minute. Okay. Let me rewrite this, what I got here. So for some of you, if you want to see what I did put in the calculator, 3.4 times 36 over 25 pi. Okay, so the next one, the radius of the surface of water, the radius of the surface of the water in the tank is increasing. So the radius is increasing at 0.75 feet per minute. So dr dt here, 0.75 feet per minute. At what rate is the area of the surface changing when the radius is 4.2? So area of the surface, think about it. If this is a cone, what's the area? What shape is the surface? The surface is just a circle. So you know dr dt is 0.75, your radius is 4.2. All you need to do is use your area formula, not your cone formula, right? So take the derivative, for your differential equation looks like 2 pi r dr dt. We actually know everything here. This is a straight substitution. 2 pi, radius was what? 4.2 times 0.75. And if you were to multiply these out, if you're confused with this, I always like move the decimals, and that would be, or 0.75 is same thing as 3/4. This would be what, 21 fifths, right? And then this also cancels out 2, so you're left with what, 21 times 3 is 63. So 63 pi over 10. That's what it is. Feet squared per minute, because this is area and areas are squared, and since it is the rate, so it's going to be per minute. Okay, so there's just one question left for you to work on. So work on that question. And if you have any questions from any of the lessons before we get started with the review, please reach out, guys. Good luck.